In Chapter 4, we look at situations where we have two variables that we look at sort of at the same time. So in Exploration 4.1, we have this situation where normally in sports we talk about a home court advantage, where when a team plays, they tend to have a better record on their home court than or home stadium or whatever than they do otherwise. And in this situation, it was just the opposite. So hopefully you've already answered number 1 with the observational units being the home games. Now again, just want to emphasize, in Chapter 4, we're looking at situations where we're considering two variables at once instead of just one. So one variable is whether the game had a sellout crowd, which is categorical and binary. And the other is whether the Oklahoma City Thunder, won the game, which is also categorical and binary. So it mentions over on the side the definition of associated. This means that the proportions or the means take different values in the two groups. So that's what we're going to be looking at to determine whether the two variables are associated. So in number 2, they ask us whether they had a higher winning percentage when they had a sellout crowd or a smaller crowd. So with a sellout crowd, 3 wins and 15 losses. So the proportion of wins with a sellout crowd was 3 wins out of 18 games. So make sure you're recognizing it's not 3 out of 15. 15 was the number of losses. There were 18 games in front of a sellout crowd altogether, 15 plus 3. So 3 out of 18, if you get that as a decimal, is 0.167. When they had a smaller crowd, without a sellout crowd, they had 12 wins and 11 losses, so their proportion of wins, I'm just using a little shorthand notation, is 12 wins out of a total of 23 home games with a non-sellout crowd, and that proportion is 0.522. Okay, so again, looking at the highlighted portion of that associated definition, number 3 asked whether the two variables appear to be associated, and the answer is yes, since the proportion of wins is different in question number 2, right? So whether they had a sellout crowd or a smaller crowd determined their proportion of wins to be different. So when a study involves two associated variables, we call one the explanatory and one the response. So you can think of dependence, right? The response variable is sometimes called the dependent variable. So here we would say the game result, in other words, whether or not they won, seems to depends on whether they had a sellout crowd, right? Because their probability of winning was different depending on whether they were in front of a sellout crowd or not. So that would mean that the crowd, I'm going to just shorten this to crowd size, but I'm putting size in quotes because normally if somebody said the variable was crowd size, we'd think that was quantitative, but just whether it was a sellout or not, but that takes longer to write. That would be the explanatory, so the crowd size might explain whether or not they won, and the game result, whether they won or not, would be the dependent or response. So you could look at it two ways. Either the game result depends on whether they had a sellout crowd, so game result is the dependent or what we say the response, or we could say the crowd size sort of explains the game result. In other words, if we want to know whether they won or not, somebody has to first tell us whether it was a sellout or not, and then we could tell what their winning proportion was. So since the crowd size seems to be explaining whether or not they won, then the crowd size would be the explanatory. All right, so the question is, why did they have a better winning percentage with smaller crowds? Is it because the sellout crowd caused them to play worse, or there's some other variable that's affecting the results?